This next module in the course is going to tackle the topic of simple linear regression, an extremely applicable and important idea in statistics. As a preliminary example, actually, we're going to look at two preliminary examples in this introductory video and then kind of tear them apart and tear apart the whole problem a little bit more in the videos that will follow. We're going to look at coronavirus deaths in the US as a function of date. This is certainly a morbid and sad example, but it's relevant and it's happening, and I feel like we might as well talk about it. So we can see that since early March, the number of coronavirus deaths plotted in the figure on the left has been rising exponentially fast. If I was going to sort of draw a curve, that's about as good a curve as my kids would draw right there. We can see that it has an exponential trend to it, right? Now, that same set of data plotted with a log scale on the y-axis shows a linear trend. And one of the goals of this module is going to be to find an equation of this orange line here, which is the best fitting line for this data. And as part of that process, we're also going to discuss what do we mean by best fit. We're also going to discuss how do we find kind of error bars on our estimate of that line, and how do we find prediction intervals for the data based on our estimates of that line. Now, paramount to the idea of simple linear regression is the idea that in all these problems, we have two variables at work. There's the variable plotted on the x-axis here, which is often called the predictor, or sometimes the independent variable. Or if you're in a machine learning world, it's often called a feature in your model. And then there's the variable on the y-axis, which is referred to as the response or the dependent variable for our analysis. Right. And our goal then is really to understand how can we model y, so how can we predict y, if we put a hat, as a linear function of x. And furthermore, how can we quantify the error in this model that would get us back to our true y values, which we're going to treat as random variables. Now, a second example, a little bit of a nostalgic one for me, is to look at some data from Moneyball. Now, Moneyball was a book that came out in the early 2000s, and it was highlighting the attempts made by the Oakland A's general manager Billy Beane and assistant manager Paul DePodesta in kind of using statistics to reorganize how they looked at players, how they evaluated players, and try and, beat teams like the New York Yankees, who had probably like 25 times as big of a budget with the use of statistics, right? So one of the things that DePodesta looked at was he was trying to break down wins, right? So that's going to be our response variable here. That's ultimately what you're interested in as a general manager. How do we get more wins? And he was trying to break that down as a function of runs difference, right? So runs difference is the runs that your team scores minus the runs that your opponent scores. So runs scored minus runs allowed. And one of the predictions that DePodesta made was that it would take 99 wins to make the playoffs, and therefore, by relating that to runs, they needed to generate 169 more runs than their opponents to get 99 wins. Now, this data right here shows a bunch of different teams over multiple years of data. It comes from the link at the bottom of the page here. And you can see this blue line here sort of shows that there is a strong linear relationship between wins and run difference. These orange lines here show on the y-axis, this is 99, so this is the target number of wins, and this is 169, and you can see the place they cross is exactly at this blue line. So again, in this example, finding an equation for that blue line is important for being able to make this prediction right here, and using statistics, you could see sort of how accurate that prediction would be. So just to give you a brief outline of the videos in this series, the next video is going to talk about the method of least squares, which isn't really purely statistical in nature, but it's a good starting point for this. The second video is going to extend that to discuss what we actually mean by a simple linear model from a statistical point of view. And then we're going to actually derive MLEs for the coefficients and amazingly show that we get the same answers as we would using the method of least squares. In the third video, we're going to look at inference and confidence intervals for the coefficients. This is where we're going to have to start treating our maximum likelihood estimates as estimators and getting some sense of their distributions and how that gives us standard errors and whatnot. And finally, in the fourth video, we're going to come back and discuss covariance and correlation and how that relates to simple linear models and what the phrase regression to the mean actually means in this scenario. So stay tuned for those.